But the 2021 era, around that time, certain supplements that we were using to target certain parts of the metabolism and the herpes viruses happened to have additional footprint towards certain biofilms and certain microbiome issues and things like that that weren't known and weren't quantified and were, able to affect changes that, we'd misattributed to it having an effect on say, like a herpes virus or an infection, when in fact it was actually targeting a different pathogen altogether or a different problem with the dysbiosis. So some of this confusing data, and I suppose it's going to be the same thing in any kind of, in vivo study, is how you correctly quantify some of these outcomes as being directly attributable to, the one key influence that you are, trying to target, and whether it's that direct effect rather than an indirect effect via, say, a microbiome alteration or something else that hadn't been otherwise known. And I think it's kind of one of the big challenges. What works, in vitro and what works in vivo are two very different things. You might understand, how something works in like a certain mammalian cell, but then, you haven't then quantified all of these other influences from different microbial species that outnumber our own cells, potentially, depending on the papers you read, 4 to 10 times, our own cells. And the microbiome, I think, is just hugely understudied at the moment. Like, it is such an area of wealth, basically, both from a sort of longevity, from a nootropics angle, from basically chronic health and unlocking these health issues. It just has not been appreciated in previous decades, and I think now that that's just catching up with us, and we're realizing how poorly that's been done.
Yeah.
It's such a really interesting area to explore. I mean, if you have a look at these microbes, you have this symbiotic relationship between these different species and our own host metabolism. And there's some sort of, poorly studied signaling where the host organism, under certain conditions, will be perhaps producing some signaling compound or some metabolites, which then, basically signal that the host has perhaps some sort of metabolic issue that would benefit from something that one of those microbial species might produce, like some other metabolite. And so if you can imagine that these microorganisms, let's look at this from an IT angle. If you consider that these microorganisms were like software patches, but the way that they activate is they bloom and they proliferate and then produce, metabolites, which are then helpful under those circumstances for the host. And so even when you're looking at somebody who's got a chronic illness and they've got microbiome dysbiosis, and you look at the data and you'll see that there might be, an elevation of certain species, just for example, like Blauschia or certain sulfur-reducing species or, Clostridia species and things where they're producing, hydrogen sulfide and whatever. And each of these metabolites that they're producing will have some sort of biological effect, which actually in some way does actually benefit the host. So you'll have, look, one really good example, I think, is 4-cresol or P-cresol, which is produced by C. diff, which is quite a unpleasant pathogen, and another 53 other species. But it has a really interesting effect because the metabolite itself ends up promoting glycolysis and inhibiting norepinephrine and epinephrine levels. So in effect, it kind of decreases the signaling for fatty acid oxidation, catabolic like energy signaling and metabolism at the same time as trying to promote the glucose uptake. So you have a group of microorganisms that are in effect acting like a drug similar to, say, metformin.
Interesting.
It does that naturally just in response to the host signaling, because there's some other fault condition where you might have, let's just say, for example, a chromium or vanadium deficiency that might be affecting the glucose transporters, or you might be having, some particular endotoxin, from a pathogenic species that is present, inhibiting, say, like the glucose transporters or some other, part of the pathway. But then another part of the microbiome steps in to try to restore that homeostasis. So our symbiotic relationship with these microorganisms is just like it really is just like a service pack, if you like, for our human or our mammalian operating system. But then when it gets really interesting is that we have interventions which we've thought to be particularly useful over the last many decades. So things like antibiotics, where we will take something that has the ability to destroy a particular species of pathogenic, microorganism. But unfortunately, it's a bit like a Hiroshima type effect, where in the process of trying to destroy one thing, we cause catastrophic change and loss of diversity of all of these other species in the process of, and collateral damage in the process of trying to remove one problem.
Hmm.
And that ongoing loss of diversity is what leads this microbiome being compromised is what leads to this chronic disease state ultimately. So it's going to be really another interesting area. Like the way that I see things moving forward in the future is that instead of, taking a useful microorganism that happens to produce a certain toxin, and then we take that toxin and then we produce it en masse in the lab, and then we sell that as an antibiotic, and we take large amounts of it and do wholesale destruction to the microbiome, we'd be better off then using the original probiotic species that it came from and having it produce a tiny amount of that toxin localized in the area where that pathogen is, not destroying the whole microbiome wholesale, and then allowing the host to continue to have that balance.
Hmm.
So, we've kind of taken a good idea way too far and then created and upset the balance in the process.
And that was going to be my exact question. Like through the use of antibiotics and just like very strong antibacterial cleaners. And this is something I noticed, especially when living in the US and when visiting the US again on holiday. Like everything smells clean. Like everything is sparkly, bleachy clean.
And not just clean, but perfumed and artificial fragrances everywhere. This was a huge difference compared to in Europe, where when you go into a beer bar, for example, it smells like beer. But not like just because it's spilled on the floor, but because that's just the natural smell of being in a place where you're serving and drinking beer. It doesn't smell like vanilla perfume.
And I think if you go around just in Amsterdam to a random bar or restaurant and you do the food inspection with the ABC grade in the US, I'm sure pretty much all of them would get a C grade. Because a lot of them are not keeping it as clinically clean and cleaning everything with bleach or ammonia. And, I think we've kind of gotten this hard on for everything being as dead as humanly possible, including the foods we eat.
Well, that is a huge issue. But the other side of that is too, it's like, look, from a marketing angle, if you've got a product that kills 99.9% of germs, what's another way of explaining that?
It
Selectively
0.1%.
0.1%. And it's the ones you don't want too. Then they become, even hardier. So like, where is it that we find all these super pathogens in basically the most clean, rooms and buildings that should exist, these hospitals? It's like there's your MRSA, there's your strep infection, there's your Klebsiella. Like if it really came down to that, if I had to get an operation, I would much rather be in a field tent than in one of those hospitals.
Yeah. And I think if we take it back to the mushroom conversation we were having earlier, when we're growing mushrooms indoor and everything is perfectly sterilized. So like when I do this, I take the grains, for example, I'm using rye berries to first do the mycelium culturing on it. And actually before that, the culture is coming from an agar plate that has been pressure cooked for quite a while. So everything in there is basically dead. And then I take the grains and I pressure cook those. Everything in there is dead. And then I keep doing that. And every time I handle the bags, I'm spraying it with isopropyl alcohol and then flaming my blade before I make incisions into the bag. Everything's super clean. The tent is super clean. And it works well. But if I look at those mushrooms wrong, they will get trichoderma. They will get infected. Yeah. Like if I sneeze anywhere near to it, everything will go wrong. Meanwhile, in China, they're just banging little dowels into logs that haven't been sterilized. They're shoving them outside just in the wild, and they're having zero issues. So same thing. Like we're taking away the complete microbiome, all of the beneficial stuff for a mushroom, and it's decreasing the figures.
With the humans, like that is literally. So once you compromise the microbiome, that is the front line. That is the first line of defense against infection. So if you remove that protective layer, it's then, up to the host's ability to break down biofilms, to deal with these, with these other pathogenic species. And ultimately, look, the host is not really capable in this modern world of keeping up, with these pathogens. We need to have these helpful species in there to protect us. And it's really, really interesting. Like if you have a look at a baby's microbiome, it's something like 80% of their gut microbiome happens to be bifidobacterium. And over time, if you look at a healthy, quote unquote, healthy adult, that might be 20%, depending on the studies you read. And then if you look at the chronic illness spectrum, you'll find it's less than 2%. And that's the problem, is essentially you have these bifidobacterium and lactobacillus species, which essentially act like the temple guards and the janitors. So as soon as you remove those, you got a mess. You're sick at the first drop of a hat, basically. The first hint of a pathogen, and now you've got a problem.
Yeah.
And so what happens? Cycle of antibiotics, and then you go and continue that cycle of destruction over and over and over again, and you never get out.
Yeah.
You were saying specifically that the lactobacillus is an important part of the defense.
Very much so.
Is this the case from infancy through adulthood for humans? Okay.
Yeah, the lactobacillus, and there's a number of different species and strains, and same with the bifidobacterium. So, you'll have things like one of my favorite Limasil lactobacillus fermentum strain ME3. It's fairly unique. It was isolated from an Estonian baby in the 1980s. And presumably they were born in a lab or something ridiculous. But this particular strain, it produces glutathione, which is amazing because it's able to degrade certain biofilms, it's able to degrade a number of endotoxins, and unlike just, for example, consuming glutathione or having IV glutathione, it does it in different parts of the gut that otherwise an oral dose would not reach. And it does that in response to, the transit of different nutrients that are going to feed the microbes on the way past. So if it is sitting in proximity of a number of these pathogens, and then it basically gets fed at a temporarily similar time to the pathogens next door, they both get very happy. They both produce their metabolites, and the ME3 species, or the strain rather, happens to then effectively suppress and kill off the pathogens. It also produces a number of other really interesting metabolites, and it's actually, according to what I've read so far, 6 or 7 highly pathogenic species that it inhibits directly. Doesn't inhibit group A or group B strep, but a number of things like Klebsiella and Shigella and Staph and just a whole range of H. pylori, a number of really unpleasant species it will kill. But the fact that it also breaks open the biofilms allows, potentially solves one of the immune blind spots that we have.
Interesting.
It's not currently in my official protocol at the moment. I would say it will be in the next update, which should be coming up very, very shortly. One of the things that I have been working towards for the next update is that we're trying to replace a number of interventions which are in the protocol to break biofilms and act as antiseptics. We're trying to replace them exclusively with probiotics, which we can then apply or administer directly to these microbiomes. So you've got something that might kind of resemble a yogurt that can go in the nose or the sex organs, or you can get probiotics that will go into an ultrasonic nebulizer that you can inhale and attack the biofilms in the lungs that are going to be responsible for asthma and COPD and things like that. And then, basically be able to directly attack the root cause of these chronic illnesses. There's another whole part of this cascade, and that symbiosis with the host that, also has to be considered around this inflammatory cascade, which I describe in this disease model, which basically comes down to intracellular deficiencies of a number of these minerals. I was talking about the iron deficiency across 30% of the population. I probably will swing back to that now, because I think it's probably a good time to mention it. But what I had discovered in my literature review was that the cascade, this inflammatory cascade, which creates this iron deficiency that we see, all the time, also happens to create a deficiency of up to 8 other minerals. It's just that nobody's looking for them. No one's testing for them. So where you see somebody who's got chronic iron deficiency, they might have chronic manganese deficiency. They might have copper deficiency, zinc deficiency, vanadium, chromium, a number of these other metals, simply because they use the same transporters and they have the same peptide hormone, hepcidin, which is controlling the homeostasis. It's just, yeah, it's basically that we've got this whole hidden epidemic of mineral deficiencies because the standardized testings that we're using, like the standard Quest or LabCorp, or here in Australia, we've got, just the serum blood testing and things, which is available in the Public Health Service. None of it is able to accurately detect these mineral deficiencies because they're looking in the serum rather than looking inside the cells. So we're looking at serum levels rather than intracellular levels. And in an inflammatory state, the two are very, very different. You can have very regulated looking serum levels while the insides of the cells are, might be at sort of 20% their normal values, which then creates these metabolic impairments, which are quite profound.
So this is really interesting. We were working together with a PhD researcher on our lion's mane project, and he had some very strange ideas, so I didn't take a whole lot of what he said as truth. But one thing he said, and this guy was from somewhere in Europe, and he was in the US for a little bit, and he said, the people in the US are obese because they don't drink enough minerals in their water. And I started thinking about it like, everywhere you go, you drink water and it tastes like zero TDS water. Like it tastes like distilled water. There's no kind of mineral thing to it. And in, for example, the Netherlands, we have really high quality tap water that's being filtered through the dunes, and that's picking up a lot of minerals when it's being filtered through the dunes. And we actually have reports of what's in our water. So like, a liter of our water will already give us 10 milligrams of magnesium, which is a pretty nice amount, and some potassium, and it's not testing for some of the trace minerals, but I'm sure they're there too. And we're drinking multiple liters of this mineral-laced water here every day. And in the US, a lot of people just drink reverse osmosis water, and then they don't actually add minerals back to it. And that same kind of idea, and you see it advertised everywhere, like these water filters that take out every last drop of mineral, like these zero water things, and like it's a good thing, and it takes out 99.9% of bad stuff. But like, is it really, or are you just removing the minerals?
Well, the other side of that's really interesting. So there are studies that also talk about the quality of the soil, and just conceptually, consider this for a minute. We have the minerals that ultimately end up in our body start off in the soil. They then get pulled up out of the soil into vegetables, and then depending on our dietary preference, we either consume those vegetables directly, or we might be consuming an animal that's eaten those vegetables or those plants. So if we were to then take the minerals that we've pulled out of the soil via plants or animals, and then we, at our very industrial level, flush them down the toilet, out into the ocean, and feed the plant life that's in the ocean, what happens to the minerals that are in the soil? Very, very obviously, they get lower and lower and lower over time. And the studies that are showing then that the mineral content of vegetables since the 1950s has now dropped by over 53%.
Wow. That's a lot.
So it's a lot. It's a lot. So we kind of need to take a step back and look at that whole thing and say, well, maybe we should have been processing the sewage in a different way. Maybe we could have pumped it into deserts and turned the deserts into, new, jungles or forests or things like that, or find a better use for it. There might have been other ways to handle it, but at the moment we now have an ocean full of minerals and a, depleted soil where we're trying to grow crops. Mm-hmm. So that's another to consider. But look, the obesity is really interesting. So in the modeling that I've done, I mean, everyone talks about obesity and considering it's like, well, why is it? Why is it that somebody, doesn't have normal satiety? Why are they hungry? Why is it that, they are storing a whole lot more fat than somebody else? And if you were to look at the metabolic pathways so you've got, lipolysis, which basically, frees up these fatty acids, and then they have to get oxidized. They have to get transported into the mitochondria and oxidized and converted, ultimately to create ATP via producing NADH and FATH2. But the fatty acids, to actually get into the mitochondria, they have to be transported. The longer ones, they need to go through a thing called a carnitine shuttle, which is, as you might think, needs carnitine. Mm-hmm. So to produce carnitine requires a few steps. If someone happens to have low iron, they're going to have troubles producing carnitine. If somebody has oxidative stress and they have low vitamin C, they're going to have trouble producing carnitine. If they've got low active form of B6, so P5P, they're going to have trouble producing carnitine. If they have low NAD, they're going to have problems producing carnitine. If they have a gut microbiome that's fermenting and producing acetaldehyde, they're going to have low NAD, which is then going to be affecting the aldehyde dehydrogenase enzyme that's in that pathway. They're going to have low carnitine. They're going to have problems with fatty acid oxidation. So meanwhile, if you were to consider at a calorific level where our energy comes from each day, so if you were to consume, let's say that we're consuming 150 grams of carbohydrates, net carbohydrates in a day. So that might equate to, let's say, 600 grams of, let's say, glucose, glycogen, whatever that's going to end up being. And if our total daily energy expenditure happens to be, just for argument's sake, 2,000 calories a day, so that means that we've got a deficit of 1,400 calories that needs to come from other substrates. So that's going to be fat, that's going to be protein, amino acids. There can be, and various other things that can provide that energy. But ultimately, the body really does want to use those fatty acids. So it presumptively stores them, and it presumptively, preferentially oxidizes them over glucose when there is a choice. There is a certain step in the glycolysis pathway, or two steps where that potentially happens. But if the fatty acids are elevated, it then basically shuts down the glycolysis or inhibits the glycolysis in a way that favors the fatty acid oxidation. But what if the fatty acids are elevated because they can't be shuttled into the mitochondria? What if the fatty acids are elevated because they have gotten into the mitochondria, but the pathway that's supposed to oxidize them happens to be low in the active form of vitamin B2, or you've got issues with coenzyme A, so you've got low vitamin B5. Any of these things that could be inhibiting the oxidation of these fatty acids then leads to the inability to burn that fat. So you continue to store it, but then the host itself is running low on energy. So what happens? The person then ends up eating more carbohydrates because that pathway may or may not be working at that time. They end up basically trying to self-medicate on another energy substrate. Meanwhile, the body continues to go ahead and store fat against future needs. And so they just continue to store fat day after day after day after day. So then you've got to ask the question, well, how is it that we get to this state? How do we get this low iron? Why is it that we have problems with, converting riboflavin into fat, the active form of, or the most active form of vitamin B2? Why is it the vitamin B5, might not end up to, creating sufficient levels of coenzyme A and then ultimately acetyl coenzyme A? And this is where we go back again. If you go through the modeling that I've done, it goes back to this chronic infection and inflammation. And once we get to the point where we have, these low minerals, then you have problems with the active form of riboflavin. Once you've got the oxidative stress issues, part of the immune activity that I've been describing creates the oxidative stress as one of the mechanisms to destroy these pathogenic microorganisms. Mm-hmm. So there's too much oxidative stress. We then have inhibition of energy metabolism. If there is, and tissue damage is the other side of this. If we don't have certain minerals, then we're going to generate the damage to the tissue by the immune response, or this creation of these reactive oxygen species. So it really just, everything just comes back to, ultimately though, the blind spots in the immune system and then the microbiome dysbiosis.
I have a question about the blind spots in the immune system. Is this something that has been recently discovered? Is this something that's been known for a long time? Do you think it's changing with our diets?
It's a really interesting thing. The blind spot's been there, obviously, for a very long time. Our understanding of that, I think, is still in its infancy. Dr. Paul Anderson is probably someone that I would point you towards. His research into biofilms has been enlightening. He talks about what we call phase 2 biofilms. And that's essentially where we have certain species that are able to produce these other biofilms which don't degrade by, just dietary, polyphenols and spices, turmeric, curcumin, things like black seed oil and various, things that people might consume just as part of their normal intake, which are able to degrade standard biofilms, but don't degrade these stubborn ones. As far as, hospitals can go, they're now just kind of becoming aware that it's the biofilms that are creating the problem. This is where we're getting the MRSA and all these other things from. Like, if you get rid of the biofilms, then a number of these pathogenic species actually die really easily from a number of interventions. but the biofilms protect them from a number of the compounds and drugs and things that are used, or cleaners. As far as that being responsible for chronic disease, yes, in certain circles, you'll see people now talking about biofilms, as basically being the basis for a number of different things, like mast cell activation syndrome, histamine degradation issues, which is, part and parcel with the model that I'm describing. All of these different things that are being related to biofilms, I would say it's an emerging area, and that if you find certain practitioners, you'll find different people talking about different aspects of it, but perhaps not understanding the nuances and the pathophysiology for it in quite the detail that I've been able to elucidate in the modeling. So it's an area that I think is definitely going to shake the pillars a lot in how we understand how we treat chronic disease. It's an exciting time, I think, in medicine.
Absolutely. And jumping off of that from chronic disease, or maybe just along the same lines, mental health as well, and how these are all related to each other.
Oh, definitely. So look, in the modeling, so what's really interesting is that if you were to have a look at the innate immune response, if you want, perhaps I could bring up a diagram and maybe step through a couple of pathways,
Yes.
which it's a little bit difficult to let me just bring this up. It's a little bit difficult to understand without seeing it, and I'll have to apologize for some of the complexity of some of this. It might be a little bit difficult for some people to understand, but other people might enjoy it.
And I think this is a good way to put it into perspective how complex it is, these things we're talking about. So just because you want to affect one thing doesn't mean you can just ignore everything else. And I think what you were saying earlier about L-carnitine, one comment I wanted to make there is, I think a lot of people who aren't maybe as knowledgeable might go, oh, okay, L-carnitine is a problem. I'm just going to take L-carnitine and then my problems are solved. But that's clearly not what's going on here. I don't think that would achieve.
That's correct. I mean, you've got to then ask the question, why is the carnitine low? It's got to be that kid that just doesn't stop asking why.
And if you add L-carnitine, maybe you make the problem worse, right? Like if it's turning into TMAO or something like that.
Well, potentially. There's always, off-target hits and additional footprint. But in this example, if we're looking at this pathway, it might be in the protocol that we're using with people who are exploring a protocol for long COVID or jab injury or ME/CFS. We're using potentially 4 grams of carnitine a day orally.
Okay.
And that's just in there to support the other pathways up until the point that we resolve the issues with the cofactors or the minerals or the influences that are affecting that pathway. Once you resolve the things that are inhibiting that pathway, then you don't need to support it anymore. So then you can focus on, other bottlenecks. And it's one of those things when you're looking at this, you kind of need to actually really think about the resilience, like the layers of redundancy that go into the engineering of the cell. It is just incredible. So by the time that you actually notice that there is a problem, some serious things have had to go wrong before you actually even, see that there's an issue or feel that there's an issue. So so if for example, okay, let's one of the favorite things that gets talked about, I guess, in the nootropics community is things like dopamine synthesis. And actually, just before I get into that, I'll just point out something that's really interesting here. If you have a look at the dopamine synthesis pathway and then the degradation pathway, what's really interesting that's been uncovered in probably the last decade has been that we actually have an endogenous pathway towards producing morphine. We have an endogenous opioid biosynthesis pathway, which gets activated by the combination of dopamine and dopal. So that means that if we have any number of the issues which are inhibiting this aldehyde dehydrogenase activity here, which converts dopal into dopac, so it could be low NAD, could be low molybdenum, zinc, magnesium, or something else that's acting as a competitive substrate, so it has a higher affinity for that enzyme than the substrates that we're wanting to metabolize, then that combination there can go down another pathway and ultimately become morphine. So if we then have a daily production of morphine, it's the same as if you were on a drug, if you've been given a prescription narcotic for a period of time, and then by continuing to take that chronically, you're going to end up with downregulation of certain receptors and pathways and things like that. So like CAMP to PKA, for example. So you end up basically with long-term homeostasis issues that even after you've removed this issue, you then still potentially have the downregulation of that system. That's going to take a while before it recovers and resets.
Okay.
But yeah, that's
So
really interesting.
one question
Yeah.
here, looking at that aldehyde dehydrogenase. Earlier, you also mentioned acetaldehyde, and I do think maybe now is not the right time, but I would like to talk about acetaldehyde at one point, and then dihydromycetine. That's a
Yeah, well,
product we're releasing as a standalone very soon.
that's really exciting.
Yeah,
We're using that in the protocol, and I'd be very happy to find a quality source of DHM available because that is something that we find very useful. Like as soon as you actually make sure that the enzymatic reactions have their cofactors, then you'd actually want to potentially promote their activity using something like DHM. I mean, there are other things that promote DHM. Taurine's another thing, which is very helpful there. And there are many other compounds that do it, but DHM has quite a unique, yeah, unique property there, and also some beneficial effects in the microbiome.
yeah,
But the
and some metabolic health enhancement properties. It's a really cool compound, actually. And one pathway that I found recently is that it enhances the level of the protein gifferin, which seems to transport and be able to locate GABA A receptors on the neurons. So by increasing gifferin levels, even though DHM seems to be a GABA A antagonist, it seems to actually, through then two separate pathways, probably enhance GABA A receptor density, which I think is really interesting for a compound like that.
That's really interesting. And there could be some extra benefits there for somebody who's had a complex history with different GABA, altering, homeostasis altering drugs and things.
Yeah.
But the aldehyde, look, the aldehyde metabolism is present in a number of pathways. So things like the vitamin B6 degradation pathway. So you've got pyridoxal, so the AL indicating the aldehyde. It is degraded into pyridox 8. If we're looking at, I'll just go back to the ethanol metabolism for a minute, ethanol to acetaldehyde to acetate.
Mm-hmm.
You see the same thing in like the vitamin A metabolism. So you'll have like retinol, so the alcohol, to retinal to retinoic acid.
And that's going through aldehyde dehydrogenase too?
Yeah, it goes through that.
Wow.
And then the same thing when we're looking at the histamine. If you look at the histamine degradation pathway, there are some distinct similarities to the catecholamine degradation pathway and the neurotransmitters. So histamine goes through DAO, which requires copper. That also has a requirement for the active version of riboflavin. And then it goes through an intermediary metabolite, which then goes through an aldehyde dehydrogenase, and it's ALDH2. So that's the mitochondrial enzyme. And that has the same old cofactors that we're talking about before on its way back.
Does DHM have an effect on ALDH2 and 1, or
Yes.
just on one of them?
Yeah, no, both.
Nice.
Both, yeah, absolutely. But it's also ALDH2 that appears to be responsible for the B6 degradation.
Okay.
It's also the same one potentially which is able to degrade the neurotransmitter metabolites as well. Yeah, it's really quite a key issue. And like, if you look at things like autism spectrum disorders, you'll see that aldehyde toxicity is one of the primary features you see there as well.
Interesting.
So once you understand that the NAD metabolism gets altered by the immune response, so the interferon gamma, so the top two interferons, they alter NAD metabolism in a way which then favors the immune response. And then there are all these different compensations and alterations which come into play, which then ultimately allow the metabolism to continue under stress. But the NAD metabolites are used basically as part of the response to produce the reactive oxygen species to then kill off the pathogens. And ultimately, part of that interferon gamma activity also gets used for other things like tissue transformation. So hormone biosynthesis, protein synthesis in general, almost all of those synthesis tasks, or the major synthesis tasks, require another metabolite called NADPH, which is ultimately produced in a major way by taking NAD and then converting that into NADP, and then taking the H from NADH. This is an enzyme called NADP transhydrogenase, and then ultimately creates this NADPH. So that NADPH is required for things like, for methylation. So some of the folate metabolism over here. It's required for nitric oxide synthase. So we've got here NOS, so that's for like vasodilation, blood flow. We've got a number of different areas which are critical to, and what I might even do is bring up hormone biosynthesis, just as an example. If you were to look at hormone biosynthesis, you'll see that there's a certain cofactor here called adrenodoxin reduced, which also requires NADPH and the active form of riboflavin. If you look at each of these reactions, you'll see that, for example, so you'd have to assume, say, that's this metabolite here. So NADPH, NADPH, NADPH. Basically, a number of the reactions vertically in the early stage of the pathway require NADPH. And again, you will see here NADPH, NADPH, NADPH. So the levels of NADPH basically are able to dictate or control or regulate the hormone biosynthesis pathway. Part of this whole thing interacts with the immune response. So cortisol, which is the other side, so you've got anabolic hormones, you've got your androgens, then you've got catabolic hormones, cortisol, and the way that they interact and control the immune response is that cortisol happens to be the primary inhibitor for interferon gamma. So under certain circumstances, if we alter metabolism in certain ways so that NAD becomes low while NADPH is elevated, certain things happen here between these HSD 11 beta 1 and beta 2 enzymes in particular, and there's other parts of metabolism as well, that regulate the conversion between the inactive form of cortisol, so cortisone, and the active form, which is cortisol. Simultaneously, there's also some other metabolism which looks for levels of NAD, glycolytic flux, levels of the active form of B6, so P5P. If any of those are low, it leads to low phosphatidylserine, which then leads to the release of corticotropin-releasing hormone, which then leads to adrenocorticotropic hormone, which then basically leads to cortisol release. And there's also from the limbic system and anxiety. So what's really interesting with that is that because cortisol happens to be the regulator for the immune activity and tissue damage, if you have a chronic infection, or if you are overtraining, or if you're leading to a state where there's issues with your ability to maintain your glycogen stores, then you're going to end up with elevations of cortisol in the evening. And also, if you're female, you're going to have the opposite effect, like at two different periods of the month, like pre-ovulation and the second half of the luteal phase, you're going to have the opposite effect where you have an elevation of estradiol, which then allows the ongoing immune activity to continue and cause more inflammation and pain, and also dysregulation of the neurotransmitters. So it's really, really interesting to see the interplay between all of this. So under normal circumstances, you should have pre-ovulation, you should essentially be getting a spike of energy in libido, and also in the second half of the luteal phase. And that will be the case unless you have a chronic infection, in which case you then end up with then more immune activity, because the primary sex hormone then leads to a state where you have less of an effect of cortisol in actually inhibiting this immune activity, which then in the state of this chronic infection then just leads to oxidative stress and tissue damage and dysregulation of the neurotransmitters, sleep, everything else, and generally not having a very good time at all. So
and what kind of, I'm sure a lot of women listening, and including Erica, would probably want to know, like, what are maybe some smaller scale, easier interventions there, and then something more complex to make sure that during those periods things work optimally.
Well, ultimately, what you want to do is remove the infection. So you get the infection, and it's really interesting. So when you look at things like fibroids and endometriosis and polycystic ovary syndrome, and all of the other related mucosal microbiome issues in the cervical or the vaginal microbiome, that could be alone one of the reasons why you might be having various different challenges at mid-cycle and late cycle. But it's something that if you were to go through the process of remediating that dysbiosis, and then which then leads to that chronic immune activation, then those tissues are less likely to be causing that dysregulation of the hormones and everything else and the neurotransmitters. The thing is, it doesn't have to be just in those tissues. It can be somewhere else. You could have a tooth infection, but then ultimately you'll see the pain and the inflammation typically in the site of where the infection is. But then you'll still have the systemic effects like the neurotransmitter dysregulation, maybe the histamine elevation at certain times, and all the other things that you might get. So you can work backwards symptomatically and saying, well, if I'm getting cramping and pain, somewhere in the sex organs or somewhere else, okay, that's likely going to be the site, of the infection and the dysbiosis. So that's a way to then sort of zero in on that. And you might then want to follow up and do, specific sequencing, like the next generation sequencing of the microbiomes in those tissues, see if there's some targets there that can be, can be hit easily. And that might be via, different mechanisms, probiotics. In worst case scenario, there might be, some other intervention, like an antibiotic, maybe sometimes appropriate. But generally it's because that's kind of just propagating that destructive cycle. It's really not something, that I would normally try to use. Bacteriophages are definitely a very interesting area to explore. And it's interesting. If you're in Russia, you can just go and buy them over the counter there. Like they're so far ahead of us as far as actually dealing, with the pathogens in the post antibiotic world that we're almost in with all of these, antibiotic resistant species. Mm-hmm. So, but I guess it really just comes back to, collect the data, see what the problem is, deal with the problem. And to do that, look, there are good tools. It's just that, they're not going to be available usually by your GP, your doctors. Your clinicians generally aren't aware of some of the tools that are actually available to quantify some of these issues. But they are something that we describe in the protocol. So, if you need to find anything more about how to sort of remediate some of these things, there's a protocol document which is on the website, which is due for an update, but it does actually link you to the tests and show you how to interpret the data and then apply that information against your own situation. Mm-hmm. So it's some of that testing, like the next generation sequencing, the tests are typically between $250 to $300 plus shipping. There's a lab in the US called MicroGenDx, which does a very good job. They've got an amazing library. It's about 57,000 different species in their library. So the data that you get back is just incredible compared to, say, running a culture or something, which tends to fail about 50% of the time. It's kind of ridiculous, actually.
Yeah, that's a really high failure rate.
Totally unacceptable, and yet just kind of glossed over. It's just amazing. Much like many of the other testing that gets used. It's just unacceptable that these things are the quote unquote gold standard of the way that we diagnose diseases. Most of them don't even work. They cannot work. Just the methodology itself cannot work or cannot accurately quantify the variables. And yet somehow we've ended up here thinking that they do.
Yeah, we see that a lot, and just I think that's a part of innovation too. We thought those things worked in the past, and then we learn new things and we realize they're not as good, and we need to keep moving forward. But I think a lot of the times in the pharma world, that moving forward doesn't necessarily happen. And you see it with a lot of the mental health tools too. I think they're about 50 years behind still.
Yeah, it's amazing how that works. I mean, what we find is, look, the expectation is if you have a chronic illness, if you have a chronic infection, it is going to dysregulate your neurotransmitters. It is going to cause, adrenaline and cortisol increase by design. It is expected to dysregulate those pathways. So, people that are being treated with these different, psych meds and things and, or other therapies, if they were to go and explore their data and say, oh my God, I've actually got this chronic infection. So what happens if you actually resolve that chronic infection and this downstream cascade of mineral deficiencies? Suddenly if you've resolved, for example, a copper or an iron deficiency or the oxidative stress, look at that. It might be that we actually have phenylalanine converting into tyrosine or through to L-DOPA. Or if we've got, other issues which are creating this magnesium deficiency, that might actually affect the AADC, the aromatic amino decarboxylase activity,
Correct. Yeah.
which then creates dopamine.
Mm-hmm. And that creates serotonin too, and histamine even. So,
and to
that's
connect
exactly.
this to the conversation about female hormonal health, a lot of
Mhm.
times a solution presented to young girls, women, is that birth control is the best answer to deal with mood issues or fatigue
Well,
issues or pain related to the menstrual cycle. But these issues
yeah,
might not be coming from a hormone problem
correct.
specifically. It could be
But they're
coming
not.
from something else.
The hormones literally just control the signaling. So all you're doing by stabilizing the hormones by using the birth control, and it might be that you're using the mini pill of just progesterone. So you're dialing back then the estradiol levels, which then mean that you're limiting the amount of immune activity, which then limits the oxidative stress and the tissue damage and inflammation. So you're kind of reducing the symptoms. I mean, you could probably achieve the same thing by, something else that inhibits that immune activity, like NRF2, for example, which is, you could use something like carnosine example, or carnosic acid also as an NRF2 promoter, or sulforaphane or something else might be helpful. But again, that's only a symptomatic relief. It does nothing for the underlying problem, which is generating this, misery day after day, but at certain peaks of it at certain times of the month.
mm-hmm.
Then so kind of follow on to, like, you probably a certain part of your audience, might be more familiar with androgenic compounds, for sports performance or other
For sure.
things.
Yeah.
Yeah. And it's the same thing there. So basically in the male biochemistry, the androgens do the exact same thing as estradiol does in females. So, what you see is that people that are elevating their levels of androgens ultimately lead to elevations of immune activity, oxidative stress, and that oxidative stress also can potentially lead to, cell damage and mutations, DNA damage, which then may or may not lead to, sort of oncogenesis. So it's
Mm-hmm.
kind of this dysregulation of or stepping in and controlling the hormones. The hormones are being altered as well and downregulated, particularly in males, by a number of these factors downstream of this inflammatory cascade. It tries to actually pull everything back to say, hey, look, there's tissue damage here, there's all these problems, there's oxidative stress, dial it all back. So you end up with hypogonadism as we age because of this, slippery slope of this dysbiosis.
Mm-hmm.
And of course, if you turn it all backwards, fix the dysbiosis, fix the mineral deficiencies, lo and behold, what happens? The testosterone levels come back up.
So I've heard, and this is a big thing, a lot of these health YouTubers are talking about that male testosterone levels have been dropping year after year. So clearly, I think you think there's some truth to it, but what really is the main mechanism there? Because I hear all sorts of outlandish theories now that it is
Well,
microplastics or the fact that we sit on seats too often and we don't ice our
sedentary
balls enough
lifestyle.
or whatever.
There is aspects of truth to a number of these things. I mean, microplastics can do a number of different, things in our biochemistry. There's all sorts of really interesting studies coming out on that. And if you look at a sedentary lifestyle, so with the understanding that the NAD metabolism and then ultimately the NADPH metabolite is actually promoted by exertion. So what I haven't described in this, maybe I'll just take a moment to actually go through that. If we look at the citric acid cycle, right? So this is like the primary engine inside the mitochondria, which ultimately generates the first main metabolite is NADH, and then we also generate some of the reduced form of the riboflavin metabolite. So that's FADH. It's essentially NAD with hydrogen atoms. There too, you've got extra electrons that then get passed through to another pathway called the electron transport chain, which then powers a pump called ATP synthase, which then produces the ATP. So the thing is, there also, just by the by, there are a number of other enzymes on the inner matrix of the mitochondria, which also are able to take and donate electrons. And they come from other parts of, the metabolism, like the collagen synthesis and some of the sulfur metabolism and lysine degradation, electron transport flavor proteins, and, other pathways. Like there are a number of different things. Everyone focuses on complex 1, complex 2, but they're certainly not the only the ways that electrons get into the electron transport chain. Anyway, one of the things that happens is that, not shown here, but mitochondrial complex 1, which is also known as NADH dehydrogenase, it takes that H, so that NADH, strips that off, and then returns NAD. Now, the electrons, which are supposed to be going through the electron transport chain, that then goes off to the rest of the pathway. If interferon gamma is elevated via another mechanism, complex 1 is inhibited. So all of that NADH, which has been generated by that cycle, instead of it then getting used for the electron transport chain, the NADH pool can go in a number of different directions, but ultimately down here to NADP transhydrogenase, which then converts that NADP into NADPH. So basically, we end up with this elevation of NADPH, which then drives all of the hormone biosynthesis, cholesterol biosynthesis, all of the main tissue generation activity has upstream influence from that that metabolism. So it's just really interesting that the innate immune response or the cytokine there is actually responsible for a lot of our growth, our tissue adaptations. So our response to exercise is actually orchestrated by an immune pathway elevation.
Interesting. Yeah. And
so this is
speaking of NADH, what are your thoughts on just taking actual NADH?
Well, it's the same sort of thing as taking any of the other NAD precursors. So like in the protocol, we're using nicotinamide mononucleotide, or NMN. I mean, you could just as easily use NR. I mean, these are only sitting kind of one step back really from NAD. You could also you could use other things like nicotinamide, you could use niacin or nicotinic acid, but you'll see that there are a number of different steps, and there are more cofactors. So if you've got, like, for example, issues with ribose or, phosphorus levels or whatever, then you might end up, or even magnesium, then you might end up being that the conversion of nicotinamide into NMN might be inhibited in some way. So you don't guaranteeing that you end up with the NAD level that you might otherwise get. It's the closer you can get to that active metabolite, the better. Now, if you're taking NADH as a supplement, where is it going to go? It's already got, the extra hydrogen atom. You've already got the extra electrons. It's going to go to energy generation potentially on, where it gets to, but it can also go towards, NADPH potentially via NADP transhydrogenase, and of course a number of other reactions. So if you were to look at the two pools, you've got NAD and you've got NADH, and then the balance between those two pools often decides the direction of these reactions, or whether or not the reaction proceeds if it's not bidirectional.
So if we're taking, for example, NADH, and it is going to NADPH, would that then mean that NADH supplementation could stimulate hormone synthesis a bit?
Yes. Potentially, okay. Yes.
That's interesting. Because we've never really looked at that angle, where we're looking at the NAD supplements as a way to enhance the process of steroidogenesis, because we're doing that with a lot of different things, like cystains and shilajit are upregulating some of those CYP enzymes, and that seems to work quite well. But then, maybe something interesting to think about for a hormone optimization stack is to also dial in the NAD plus portion, the NADPH.
It is a thing, but look, the key takeaway from this is that the immune activity and exercise are required. Yes. So if you're living in front of your computer all day, you're not going to be expecting to have elevated hormones or optimum hormones.
Yeah.
So that lack of activity. But then if you've got problems with the iron levels, that's going to be affecting the heme required for these CYPs here. If you've got problems with low calcium, heme, iodine, selenium, tyrosine levels, which goes back to, again, oxidative stress and iron and things like that, then you're going to have problems with, the riboflavin metabolism, which then affects thyroid, which then affects the riboflavin metabolism. It's actually a simple little two-step pathway here. So we've got riboflavin, which then requires thyroid hormones, so selenium, iodine, calcium, heme, funnily enough, FAD, there's a bit of a circular thing there. And it uses riboflavin kinase and zinc to then convert riboflavin into flavin mononucleotides, FMN, which is anyway, I'm going to be having a brain jump there. But it also then MGATP as the main cofactor. So you then have FMN, which is biologically active. It's used in the B6 metabolism, for example, PNPO, that uses FMN. There's another aldehyde oxidase here, I think using FAD and PMPO there as well, which is FMN. FMN is also used by NOS over here, I think, from memory. And yeah, anyway, but then the true active form then goes through FAD synthetase, which is requiring molybdenum. And what we see in the intracellular data is that you're going to have a number of these end up being low. But if you go and look in the serum, you don't find them. You don't catch them. Like if you look at the serum levels of calcium, they're normally within range. Like unless you're actually looking inside the cells, and it has to be white blood cells, not red blood cells, because they have mitochondria, you're not necessarily going to have an accurate representation of the calcium levels. Definitely not in the definitely not in the serum. Just just pointless. But yeah, it's really, look, it all comes together once you actually have proper data. And that's what we've been doing.
And it's interesting that you mentioned, like, look, you can see here in the data, you need to be exercising. And that's something we tell a lot of people too. Like, supplements aren't magic. You're not going to be able to take something, sit behind your computer, and get super lean, 8-pack, jacked, ultra human. Like, you have to put in the work, and the supplements are there to support these pathways. They're there to support the exercise and the recovery from it. But the real important thing is that we're sleeping well, we're exercising well, and we're eating well. Like, all of the other stuff is a nice bonus, and we don't necessarily need it to survive, but it's nice to be able to optimize it. But some of these things that are just important and free, like you can exercise for free, you don't need to spend hundreds of dollars on supplements.
That's right.
It's a no-brainer.
So one of the problems then with things like chronic fatigue syndrome or long COVID or jab injuries is that you have exercise or exertion intolerance. Like you literally, because of the amount of oxidative stress that's being generated by the immune response and because of the mineral deficiencies, your exertion just increases that oxidative stress pool, which then inhibits the energy metabolism, and then the whole thing shuts down again. So the basic things that you would do to try to get healthy potentially hurt you more unless you're actually doing the right things to support those pathways first.
Yeah. And you know, for us, we're technically, for all intents and purposes, we're only concerned with people that don't have any chronic issues. They're all healthy people. And I think in that sense, I think for someone who responds well to exercise, like, go out there and exercise a bit more, because it's probably the best tool you have in your arsenal.
It really is interesting is when you study the metabolism, it's understanding that basically all of your biological processes are benefited by exercise, that it expects that you are going to exercise. And libido happens to be a really, really, really good blunt marker for blunt tool for understanding the hormone biosynthesis, the neurotransmitters, all the things that basically have to be working for you to have a healthy libido. So once the libido is out the window, then you can kind of then start wondering if there is, a bigger problem that needs to be, investigated.
Yeah.
So it's, yeah.
Yeah, when I'm in a period of like low energy and depression type of thinking, and I'm just laying at home watching TV all day long, the first thing to go is your libido. That's clear.
So yeah, it's a really good just general, inference towards the rest of your health status. And look, as far as testing goes, there the test that I would recommend. There is a lab in the US called Cell Science Systems. They've got a cellular micronutrients assay, I think it's called, CMA, or which is part of their larger test suite, CNA. We are linking to a reseller. One of the resellers in the protocol. The test itself, I think, is $264 plus you've got to get a blood draw and you might have some shipping. But the data that you get from that is this huge report. All these different, like the minerals, the coenzymes, the amino acids, and various other vitamins and other things that are reported in that report. It's just that there is really nothing else as useful as that data in trying to understand what it is that you should be targeting. So rather than going out and buying 50 supplements and thinking that you need to take them for some random reason, get your data and actually go, wow, look at that. I am low in X, Y, and Z. Or, hey, you know what? Maybe I'm perfect and I really, now I'm ready to take a nootropic to boost me above and beyond where my baseline, actually, my true baseline is, rather than my inhibited baseline that I think is normal.
Yeah. Yeah, I think now that we have access to all of these tools and we can get a really clear idea of what's going on, it's a no-brainer to use those tools, especially now that they're starting to come down in price. Because I feel like in the past, sometimes it could cost thousands of dollars to do something like this. But with new technological advancements, yeah, now it's costing a few $100s. And I think a few $100s is a very worthwhile investment into your longevity, basically, and just your day-to-day happiness and yeah, being an effective human out in the world.
But I think it's just amazing that these panels are not available through the standard channels.
Yeah.
It's mind-blowing that we could be here basically saying, okay, yeah, look, there might be 4 labs in the world that I'm aware of that can do this kind of test. And it's such a fundamental thing.
And it's interesting that most of it is happening in the US too. And I think the time that I spent in the US, it was great being there and seeing all of the crazy level of innovation that's happening. Like, the sky is the limit, it seems like, in the US. And just in the 6 years I lived there, I saw all sorts of things pop up, from like blood testing to wearable glucose monitors and all of this stuff, like things that we had no idea about a couple of years ago. Now we can track all of these really complicated biological functions. And both Eric and I got a fitness tracking watch like a month ago or so. I used to have one in the past that didn't have one for a long time. I was like, I need to just track at least my sleep. I think that's really interesting. And I think just wearing it and tracking everything, I know it's probably not as accurate as it should be at this point, but just having some trend data is nice. And we're feeling healthier and more energized just by like almost competing with each other. Like, hey, what was your sleep score? Oh, mine was a couple points higher than yours. Try harder next time.
Programmable creatures, I think. And I think gamifying a lot of these things is a good way to succeed.
Yes. Yeah, it makes it fun. And with these blood tests too, like I'm quite curious, and I think it would be interesting maybe even I can do some of those tests and I can share them on a video, and maybe even you and I can go through it and you can kind of point out some things, and then I
medical advice, educational advice.
Exactly, just fixing some imbalances in terms of minerals, and then to do the test again and see just feeling wise, how am I feeling, maybe data wise, what's going on, and seeing some of that, because it is interesting to get a look. I think we've given people over what episode is this, 31 or 32? We've given people a pretty in-depth look into our life, so it would be interesting to show some blood tests too, put it all out on the table.
Yeah.
No, that'd be quite exciting, I think.
Yeah.
Good way to keep it real, and look, I think that would be wonderful. Yeah, look, if you wanted to organize that, and I'd be quite happy to come back and do that with you.
I would be very curious. And I'm also curious, aside from these just general markers that you're talking about, are there also tests available for these bacteria or infections related to biofilms? Is that also available generally?
Yeah, definitely. Like, again, the specialized labs. The funny thing is the microbiome seems to have become a bit of a hot topic in an area. So there's a number of different tests out there. And unfortunately, because of that, there's a lot of confusion as to which tests you should use under which circumstances, and the different methodologies, and some of them more helpful for, understanding certain things, and the way the reports are formatted to kind of narrowly focus on what they think is important. I'm not aware really of one test that truly does everything properly. So particularly with the gut microbiome, and look, there's a huge problem with gut microbiome sampling, because just conceptually for a moment, if you consider what you're sampling, right, you don't have a homogenized sample. So the species and the counts and things that you're looking at, it's not like you've got a liquid sample that's been blended and you've got suddenly this uniform distribution of all these different species. So if you're trying to gamify it, going back to what we were just talking about, and you're looking at the counts of these different species and saying, oh, well, that's high, or that's low, or that's whatever, the problems with that sample, just purely the methodology, you're going to have false negatives. Your counts are going to be all over the place. It might be that the part of the specimen that you sampled happens to have an abundance of certain species and a deficiency of other species. So trying to use the counts that are in those reports as a true understanding of what's there is just a flawed idea, as opposed to other microbiomes. So if you're doing like a vaginal microbiome or nasal microbiome or something, that is a lot more actionable data, or something that you can just gamify or use as a direct interpretation. But the
And is
gut
that because
microbiome,
it's less complex, or is it related to the
just
tissue?
a liquid sample versus a solid sample.
I see. Okay.
Yeah, I don't
So
think a
that's
whole lot of people are blending up the poop.
no.
Yeah.
So
Understood.
that's yeah, it's one of the challenges. But the thing is, that's not really discussed. It's not described in the test results and the marketing and things like that. So, somebody that might go out and do one of those tests and then follow up after doing all sorts of crazy things trying to rectify it, and then get frustrated because they're not seeing any differences objectively, even if they're subjectively seen changes. Be chasing their own tail on something simply because the methodology shouldn't be used that way because of the limitations.
And
So,
that makes it quite inaccessible for your average person
mm.
who's trying to approach health issues, maybe not through the most typical way, but through looking at gut health.
That's it. Look, so what I've been trying to work towards to accommodate some of that is a different way to interpret it, which is essentially if you've got a database of all these different species and you understand what the substrates are that they will take and the metabolites that they produce, you can then look at the trends to understand what it is that they're trying to patch. So if you've got 10 species that are all doing the same thing and there seems to be an abundance of them, you might say that there's a reasonable expectation that they're trying to solve a problem with, for example, glycolysis or some other issue, if you've got an abundance of, say, some Clostridia species or other things. So what I'm working on at the moment is basically that database of microbes and strains, like species and strains versus substrates and products, and then trying to use that as a better lens to try to interpret all of this. So it's
Quite
yeah.
a
Anyway,
project.
yeah, one of many ongoing areas of research. It's been quite a so we're probably about 14,000 hours of modeling in at this point in the last 3 years alone.
That's, yeah, I
And
can
that's just
imagine why
me.
you needed a bit of a break recently. Yeah, yeah, that's a
Yeah.
lot. It's a lot to keep
It's good.
track of, and yeah, I think some people also don't realize like the mental strain it takes to read through this research all day. Like sometimes when
Mm.
I'm doing research for new products or writing or the podcast, like my brain literally hurts afterwards. It's like I've been working it out, and it needs to recover. Like I've kind of
Mhm.
noticed that my brain is very much like my muscles. I can't do really intense brain exercises day after day. I need some break too.
Yeah. Well, I mean, if you look at that, and sleep is kind of one of the critical things that's required to clear a lot of the metabolites and things that are produced during normal, day-to-day tasks and
Hmm.
cognition. Things like the dopamine metabolism that we are talking about before, some of those enzymes are upregulated dramatically during sleep and only during sleep, and they just sort of trickle along during the day. But
Hmm.
there are other things like DHM, for example, that might promote that activity. And so even if your sleep is not 100%, you're able to keep the clearance up, which then means that you might be fresher the next day.
Yeah. And I think that's a really interesting topic to also explore. Like, there's circadian control of certain enzymes because, like, looking at some
Mm.
of these CYP enzymes, even in the process of steroidogenesis, a lot of the CYP or the cytochrome P450 enzymes seem to be under circadian control. So
Mhm.
they're, I think, like the CYP3A4, which metabolizes caffeine, I think it's less active at night than it is earlier in the day. Or I might be flipping that around, but it's one of the other.
So
Yeah.
if you have a look, most of the P450 stuff is NAD dependent. So then you've got that overall interaction. It depends on the person, the metabolism. You've got that overall interaction with the day-to-day levels or, intradaily levels of interferon gamma versus cortisol. So you could expect that under certain circumstances, whenever cortisol is elevated enough, you should see potentially higher levels of NAD, either via the kynurenine pathway leading to enhanced NAD biosynthesis, or simply the inhibition of the interferon gamma, meaning that mitochondrial complex 1 is working, so the NAD redox is actually working. So that then has the knock-on effect. It really depends on what the cofactor is for the particular enzyme itself. So if it's NADPH or if it's NAD or if it's, whichever it happens to be.
Yeah.
3,4-A is a particularly interesting one because it also happens to be the main degradation enzyme for the sex hormones as well, and many other things. And there's various different, compounds that will inhibit 3A4. So, everyone knows about grapefruit, and then there's pepper, and there's, all of these other things that actually inhibit it.
Mm-hmm.
So,
what are your thoughts actually on inhibiting those cytochrome P450 enzymes kind of willy-nilly? Like you see a lot of people putting piperine in. We've actually started to do it with a few of our stacks too, because we'll try it with or without piperine. Just a 6 milligram dose, which is really low. And we'll notice like a difference in effect sometimes. But
you should. I mean, piperine or beta-caryophyllene both should have that pronounced effect. I think, look, relative to the amount of pepper that somebody might be consuming on a daily basis, I don't think there's any risk or harm in it. And I think ultimately the homeostasis resets relatively, quickly. So, but you might get a burst for a short enough period of time, or relative period of time of activity, or sorry, an inhibition of inactivity, which then allows for an elevation of a particular metabolite for a longer period of time. And I think, look, there is a lot of sense in that when you're trying to achieve a particular outcome. And I don't see it being problematic.
Yeah, that's kind of been our end conclusion too. Of it's not like we're giving people a gram of piperine or something. Like this is not beyond the realm of what you could achieve through just dietary. Like if I crack a bunch of pepper on an egg, I'm probably also getting about 6 milligrams.
So it's a short-term boost to a range of metabolites. And I don't really don't see it upsetting the homeostasis on a long-term basis or anything, like anything that I would be concerned about. So you might find that some people who have, we were talking about before with, like, for example, premenstrual stress or the inflammation and various other things. So like, pre-ovulation and, at the later half of the teal phase, you might find that at those times, those people might be more sensitive to piperine or 3A4 inhibitors.
Yeah, makes sense.
But, these are one of many variables that you might have to control for.
Yeah, absolutely. Well, that was a fascinating conversation. I
Really?
learned a lot. And,
Yeah.
And I'm sure our viewers learned a lot too.
Yes, thanks for joining us and sharing all of this. It's really fascinating to talk about and to consider all of the different factors that we don't think about that might be contributing to different higher, lower energy levels or issues related to hormones, menstrual cycle, also androgenic hormones, the importance of exercise and gut health with all of this. We think about it a lot of times from the plant extract perspective, just from Nootropics Depot, and talking about new supplements and trying new supplements all the time. But the factors that might be causing our energy levels to change or, mental health to change could be much, much beyond what we're consuming. And this is something I'm very curious to explore more after this conversation.
Something I learned in college, and it's coming again here, and it happens to me almost every day. When I first did my first entry-level psychology course, they said, serotonin makes you happy, dopamine makes you motivated, norepinephrine makes you focused, but also a bit stressed. But then in the second course, they said, remember what we told you about that? That's too simple. Forget all of that. Now we're gonna go look at all 14 different serotonin receptors. And then the next course, it was, well, forget about that because it matters what pathway it's in. So it keeps getting more and more complex. And I think with supplements too, the more and more we learn, we have to abandon some old ideas and embrace new ideas. And I think one of those new ideas that's clearly up and coming and a big part of your research and a big part of what we're looking into now is just the microbiome. It's been such a neglected part of the whole strategy for such a long time. And I think now it's really time to start looking at that and how we optimize it.
And not just the gut microbiome, all of the microbiomes.
And all of the microbiomes, yeah. And then also, of course, all of the supporting factors there. And at a certain point, we'll probably go, that's too simplistic. Hopefully in 20 years, it will get even more complex. But
then you start looking at things like environmental toxins and, glyphosate and various things that are
Yeah.
damaging the microbiomes and it's just a rabbit hole after rabbit hole when you're looking down that.
And this was our lab director was at a conference and they were talking about glyphosate and had to detect it in humans to see like who has been consuming glyphosate, like how widespread is it? And one of the researchers had a pretty smart idea. Let's test people's poop. Like it should be in there. It will be unbroken down. It will just be in their feces. And they did it, and 97% of the samples they tested positive for glyphosate, which is insane.
The interesting thing is too, is that if you had a look at our neurotransmitter pathways, like a number of the precursors are actually generated by the microbiome via a pathway called the shikimate pathway. And that shikimate pathway happens to be inhibited by glyphosate. So if you are suffering from glyphosate toxicity, or your microbiome is, you now have a reduction in the substrates required for your neurotransmitter synthesis pathways.
Yeah.
So it's insidious. You find that stuff in breast milk even. It's There's one of my many bugbears.
Yeah.
But hopefully it's something we'll see less and less of in time being used in, food production. But I think it's a long time before it's out of the whole food.
Yeah, I think it's kind of unique because in the Netherlands, we're lucky enough to be close to 2 organic farms where like we can go and basically see the animals that we're eating, see the vegetables that we're eating. And it's all just right there. They're clearly not using any type of shit. And that's what we eat. And
Well, they're using a lot of shit, but not so
oh
much.
yeah, it's not the bad stuff. We want the shit.
Yeah, exactly.
And that's what we're used to eating. Like we go completely out of our way to travel here once a week and get all of our groceries there. But then when we traveled to the US and we were in the middle of nowhere in Nebraska and all we could eat was really like perfect textbook cartoon looking vegetables from the local Walmart, we didn't feel so good. I wasn't regularly going to the bathroom, and I was looking up, for some reason, an old post of Paul came up from like 8 years ago, and he said, there's something weird. Whenever I leave the US and I go somewhere else and I'm there for a month and I eat, I feel great. And then I come back to the US and there's this weird histamine response type thing and I feel off. And a lot of people apparently were mentioning it back then, 8 years ago, and Paul never figured out why. But now we kind of noticed it too. And we noticed it like moving back to the Netherlands, like my beard started getting fuller and thicker. Like, what is that? Is that there's higher humidity here? Is it there's something different in the food? Like I feel stronger and happier here. Yeah. So
I mean, we've seen that repeatedly on the protocol. People's hair starts growing back. All of these things start working. So I think, look, America has a number of challenges, but food supply or quality of the food supply is definitely a big, big problem. There's other things that, I'd love to talk about in perhaps another conversation, but, the way that the environment is set up for a number of reasons and certain events throughout our childhood definitely set us up for chronic disease. And it seems that the more quote unquote developed the countries are, the more we see the prevalence of these chronic illnesses.
It was just funny. I lived in Malaysia for a long time, and we were fine. We were eating the local food, and we were fine. But when our Western friends came, we had to be really careful with them. We had to make sure that they weren't eating exactly what we were eating. Like, you couldn't eat the local ice cream because there were some bacteria in there that just immediately triggered diarrhea and things like that. But the locals are totally fine. And we've, yeah. And we've been to places where I've seen them and this was pretty sketchy to me even. We're in Laos somewhere in like a tiny border town that there was a bunch of trading going on, and we were with 2 guides and they said, you got to eat at this restaurant. They make the best fried rice. Okay. It was literally like a shack over some dirt, and we saw them cutting chicken that they had just killed, I think. Like, we saw that same chicken running around a couple minutes earlier. And then they were cooking it, and then they started cutting cucumbers on that same board where they cut the chicken, and with the same knife, and they just put those raw on top of the fried rice, and we were kind of at this point like, fuck it, we have to eat. So we just ate it and we were fine. Like, how does that happen? Like the chicken here, I think if you do that, you get pretty sick. But not there. Like this chicken that's just running around in the jungle and it's all being cut on the same. We might have just gotten extremely lucky. But I think
Maybe.
if you look at how resilient people are there and what they're eating and how they're cooking, and having spent quite a bit of time in the jungle with some of these people, like it's a completely different thing.
They're microbiomes. You would want to have the microbiome of a Kalahari bushman than a city dweller.
Absolutely.
You know,
Yeah.
and that's the thing. You're exposed to pathogens all day, every day. It's the resilience, the capacity of your microbiome to absorb that and turn that into a non-event. That decides whether or not you end up with, an illness.
Yeah.
I think we've reached a good point. I think
Yeah, we could
we're
clearly
all quite
keep going. Yeah.
saturated
Yeah.
at this point. But there's a lot of interesting potential future conversations that can be had about this.
And the funny thing is, we only really scratched the surface.
Yeah.
Yeah.
Yeah. Yeah. This has been great. And yeah, we'll follow up with just normal phone calls and stuff like that too. But I think it would be interesting to do this again sometime.
I look forward to it. Well, it's been wonderful. Thank you for having me.
Thank you.
Of course.
And for everybody who's listening, where can we find more of your research and just the history of the different projects that you've worked on over the years related to what we talked about?
So the current stuff, if you go to the website bornfree.life, it's a few links deep, but there's understanding the model, and then you can see the updated model page that's in there. And then all the diagrams that I was referring to today, you'll find them there. There is also some videos. The second one on that page is probably the most friendly, but still highly technical walkthrough of the disease model highlights. There's some additional text below the diagrams. I'm working on some bite-sized, easily digestible, shorter videos for each of these pathways, which then relate back to the overall model. That's coming in time. But yeah, look, at this stage, there is definitely an abundance of information for somebody who has a decent taste for biochemistry and wants to explore it. And the protocol as well is also linked from that page.
Okay.
Great.
So definitely go take a look and read further. And thanks again for everyone who's listened. And thank you for joining us and sharing all this. And I'm looking forward to the next conversation.
Me too. All right.
Excellent.
See ya.
See ya.
Bye.